My name's Bert, and I'll be going over the bicarbonate buffering system. So your bicarbonate buffering system is your most important buffering system, right? Basically, a buffering system is what controls the pH levels in your blood. And as we all know, normal pH levels are from 7.35 to 7.45. pH levels, if they decrease to 6.9 or increase to 8.0, will mean death. Now, what does the bicarbonate buffering system do? Well, before we get into that, we first got to know what it is. So the equation for the bicarbonate buffering system is CO2 plus H2O. So carbon dioxide plus water interchanges with carbonic acid, H2CO3, and that interchanges with a hydrogen ion plus HCO3 negative charged, which is bicarbonate. Now the whole reason we have this equation right here is because there's two sides to it. There's the respiratory side and the lung side. Or the respiratory side and the metabolic side, which metabolic is your kidneys, respiratory is your lungs, right? So this side right here, bicarbonate is absorbed and excreted in the kidneys as well as hydrogen ions. In your respiratory and your lungs, carbon dioxide is secreted and excreted as well as water is as well. So there will always be a dynamic balance of CO2, carbonic acid, hydrogen, and bicarbonate within your body at all times. This is a way so that your body can buffer in between those pH levels. So the whole reason we have this buffer system is to keep us within that normal range of 7.35 and 7.45, right? So how this works is your buffer system is constantly going. So if we have too much CO2, our pH will go down, causing acidosis, right? Too little CO2, our pH will go up, causing alkalosis. It's the same thing for the other side, right? So bicarb, as we all know, is a base, and a base is anything that can bind with a hydrogen ion. So if we have too little base or acid, we will go into acidosis, which means our pH will decrease. If we have too much bicarb, it'll absorb too much acid, causing our pH to increase, causing alkalosis. Now, this whole process works when CO2 is dissolved in the blood, where it is combined with H2O to form carbonic acid using carbonic anhydrase. Carbonic anhydrase is an enzyme found in your red blood cells that will transform CO2 and H2O into carbonic acid. Now, carbonic acid, as seen in the middle, is a weak acid, right? So that will then dissociate into a hydrogen ion and bicarbonate. And this process is interchangeable both ways. Bicarbonate will combine with a hydrogen ion because bicarbonate is a base. So, and a base is anything that binds with a hydrogen ion, so that will combine, forming carbonic acid. And then the carbonic acid will dissociate to the left and turn into CO2 and water. Now our lungs work to expel CO2, which CO2 in itself is an acid. As I said earlier, too much CO2, we become acidotic. Now this is the most important buffering system in your body because it is constantly working and constantly trying to maintain all bases and all acids. Without this buffering system, we would become acidic or alkalotic, meaning we would die. Now there's a whole bunch of different types of acidosis and alkalosis. There's respiratory acidosis, which means we have too much CO2 when our lungs cannot get rid of it in time. So that means our other side, our metabolic side, will pick that up instead and function out to get rid of hydrogen ions and absorb and keep more bases in order to balance that CO2 out. Now, our respiratory side is a very fast compensatory mechanism, right? That works fast to expel CO2 and retain water. However, our metabolic side, or our kidneys, is a very slow process, as you are not breathing as much as your kidneys are working, correct? So if we have respiratory acidosis or alkalosis, us as medics, we can fix that. Using CPAP, BiPAP, stuff like that, we can ensure that they are taking the appropriate breaths in order to eliminate or absorb more CO2 in order to bring that acid pH level back to a normal range. However, on our metabolic side, there's not much us as medics we can do. This is because usually if there is something wrong on our metabolic side, they are going through renal failure. Meaning we are not able to do anything. As a paramedic, our job would be to get them to the closest, most appropriate hospital. So in order to wrap everything up, your bicarbonate buffer system. It is the most important buffer system in the body. There's a dynamic balance between CO2, hydrogen, and bicarbonate at all times. If it moves to the left of the equation, that is a respiratory mechanism. If it moves to the right, that is a metabolic mechanism. This whole process is triggered by a change in your pH levels. And what are normal pH levels again? 7.35 to 7.45. An acid is anything that can donate a hydrogen ion or dissociate into anything else, and a base is anything that can bind with a hydrogen ion, forming an acid. Thank you.